So have you ever wondered what it's like to use an EV to tow a small adventure trailer? We're going to talk about that in today's video, so stay tuned. Hey, today we got a great one for you. We had a customer come along. His name is John. His family and two young boys decided to take our rental trailer up to PJ Hoffmaster State Park, do a little camping. Well, with that, the interesting part about talking with John was that he had an electric vehicle. I was so excited. He had a Tesla Y. For him to show up to our house, and we got to pick his brain about electric vehicles, how they all work. Unfortunately, my interview video did not work. It was one of those moments where the video kind of disappeared into la la land. We don't know where the video went. So I was really excited to see what kind of range did he get, what were his thoughts about towing a small trailer. So without further ado, we'll get into John's video and then we'll see you at the end.
Almost ready to go. Everything hooked up, everything loaded up. This Tesla Model Y with the hitch accessory from the factory. So 7-pin connector. Everything looks fine. Kids on the car. Let's see. Hey, everybody ready? Yes? Say yes.
Yes!
Where are you going, man?
No!
Let's go. Bobby. Okay. Here we are. 288 miles or 90%. Let's see how far we're gonna go. I'll put it as soon as you connect the trailer. The Tesla shows this. It disables some features. It helps you with the towing. And can you add the address here, please? Where are we going? Let's see. We're gonna do some measurement to see how much range we lose when towing. It's usually a lot. It's probably gonna be at least half the range. So we'll see. Going from St. Joseph to
in 500 feet, turn left onto South Roosevelt Road.
So let me see, how far is that? It's about 90 miles. And the estimated range so far, the car thinks we're gonna be at 36%, but we're not gonna be at 36%, we're gonna be at less for sure. So we'll have to see. Let's go. Of Tesla is that it measures very well a lot of things. There is a couple of ways to track our travel. One of them is on the travel consumption meter. We can see here a couple of things. We can see this is basically the consumption in watts per hour, watt hour per mile. The higher, the bigger the consumption. So basically lower range. This line here that says rated on the right, basically if you're closer to that line you would achieve the expected 326 mile range of the car. The higher you are above that, you're gonna get less range. So we'll have to see how much this is gonna be. We're so far not going too fast, so we're still inside the city. It also gives us some prediction. Typically the prediction is I don't think they know what's hooked up and what kind of efficiencies we're going to get. So basically the green line is, I'm gonna say, the best case scenario. We know for sure it's gonna be worse, and it's already started to detect, so it creates the gray line. So we'll see. So it's gonna be lower than 38% in the end. The other ways we can see the travel is here on the menu, there's a trip menu, and we can measure. There is a current trip, which is every time you start the car, we can use that. We can use since last charge, which is gonna be, all of them are the same, since last charge, trip A, and current trip, because they all start, I reset them all at the same time. So what we're gonna do is gonna be driving this first part of the trip kind of slowly because we're inside the city, and we're gonna see how much watt hour per mile we're going to get. And after that, as soon as we hit the highway, we will reset one of these counters. I'll see which one, and then try to compare in the highway at maybe 60 or 70 miles per hour what the consumption is. And in the end, we'll see what did we get. Okay, so we have been driving for 18 miles. I don't know what the average speed was. Probably not beyond 50. And we got so far 477 watts per mile average. And now we're gonna go up probably about 70 miles. And we're gonna see what the impact is. So let me reset the trip. I'm gonna reset the trip A. And we're gonna use trip A to measure the second leg, and the current trip will still have the total consumption of the trip.
I can fly. What? How can you fly? I can't.
Okay, we arrived. We were eager to set up, and there's my wife finishing setup, lights hanging in there. Let's take a look at the stats so far. So we did a 92 mile, if you can see that, 92 mile travel. We used 48 kilowatts at 518 watt hour per mile. That is a little less than double standard, so I think I lost about half the range. We left with, I think it was 280 or 290, and right now we're at 72 miles of range, standard range left. So it did drop significantly, and I still think it's mostly because of the aerodynamics, more than weight or anything else. So that's it for now. This is the setup. Some friends over there. This is the hiker trailer. A couple of things if you're gonna if you're gonna charge on a campground. Number one, of course, you can use the 110, right? Typical campgrounds are gonna have 110 volts, just a regular household outlet. Or if you want to use one of these, this is I think it's a 1430 or something like that, the standard, that you can charge at a higher current, just a little bit better. You will need an adapter because the way that's hooked up is a little bit different than a house 1430. So you need an adapter, and the only adapter found was from this company. Well, you can find others, but you can find an adapter that goes from 1450, which is this standard, to 1430, which is this other one, and then you can charge your Tesla in your campground at that bigger outlet. But then the other thing you have to remember is then you may need to purchase this. If you have a Tesla mobile charger, you're gonna need the 1450 adapter together with this, with the 1430 adapter, and then you can charge. Other important thing is remembering to set the current for charge at 24 instead of 32, at least in the case of this accessory. Otherwise you can also trip the breaker. So I usually just put 25, 24, 25, and that's fine. You can see here also part of our isolation for the car. Kind of useful to avoid people spying inside, or also keep the heating, because it's a little bit insulation. One of the big advantage of electric cars is their efficiency, right? It's cheaper to run on them. What most people don't realize about them is that it's not just about the electrical motors that are much better than their internal combustion counterparts, but the design of the car, the way it's designed to be very efficient as you're cutting through air, as you're driving around and going fast in highways. That design makes a big chunk of their efficiency. As I was toying with my Tesla Model Y, I realized that was the biggest factor out of the three analyzed. So we're talking about weight. That did impact probably the range a little bit. The temperature, if you're driving in colder temperatures, that's known to be very bad for electric cars. But then the biggest one was the drag. I tested two different trailers, a Hipcamp trailer, and I tested a Hipcamp Wide 6 model, and I realized that it doesn't matter all those factors too much. It was always about 50 to 60% range loss, depending on the speed I was going. So the only way I was able to increase my range was by reducing the speed. So that tells me really the efficiency, the loss was mostly because of that drag. So unless the industry evolves and figures out ways to design teardrops or trailers or things that are going to be towed behind electric cars that are way more efficient, way more thought to be able to cut through the air more easily, the effectiveness of using electric cars to tow is going to be severely impacted.
After seeing that, what do you think? You up to buying a Tesla? A Ford Lightning? Some of these other ones? I'd love to have the Hummer EV. That'd be awesome. To be able to tow a small adventure trailer, I'm sure you'd get a lot bigger range. Obviously, a Tesla has a range for the size batteries it can carry on board. And these bigger trucks and four-wheel drives and SUVs that are coming out in the future, it's going to be amazing. I've even seen some hybrid combinations where you can tow an electric vehicle, and some of the trailer manufacturers are looking at building the whole bottom base of the trailer is batteries. So your battery bank can basically work in tandem with your electric vehicle, and the two can be married together where you can basically be charging your car while you're traveling to get further range. I think that's where it's all going. Awesome. The thought of being able to plug in your car in a campground and charge it up is awesome. But for the off-grid community, that's where the benefit of a trailer with large stack of batteries could be able to charge your car and get better range by having a better power supply or battery system in your adventure trailer. What do you think? Put it down in the comments. Would you buy an electric vehicle? Do you think they're worth it? Do you think they're overpriced? Put your thoughts down in the comments. I'd love to hear and get a discussion going. With gas at $5 a gallon, who knows? We'll see where this all ends up in the end. So with that, thanks for watching the video, guys. We'll see you in the next one. Make sure you get out and do some camping.